Hey, what's up, you amazing hackers? Hope you're doing well today. So, welcome to my video about the API top 10, because of course you have the OWASP top 10, which is interesting, of course, but the APIs is something that are really interesting in my opinion, because the normal OWASP top 10, they just do describe the right vulnerabilities, of course, but not a lot of people know how to actually approach an API, and that's what I want to learn you in this course. Now, first of all, it's really important that you understand that there are different API architectures like REST and SOAP, or a combination of both. I'm not going to bore you to death with what they are. You can read all of that in the course themselves. There's PDF for it. And there are also API types. Now, internal APIs, that's pretty obvious. That's APIs that are only approachable from the internal network. They require authentication. And then there's also third-party APIs, which are partner APIs, and they're used in case of like let's say, for example, you have a website and you want to do Google Analytics. So that's third-party API that you're going to talk to. That's not your own internal API. So there's also composite APIs as well, which is a mix of different types of APIs. So it's all pretty complex, but if you think about it, in essence, it's not that hard. You don't have to think too deeply. Now, in this video, I want to focus mostly on the top 5, so 1, 2, 3, 4, and 5. As you can see, I've written 6 and 7 already, but I'm not going to handle them in this video, just to split it up, and because of the boredom, of course. These videos are going to cover the top 10 most discovered vulnerabilities in production. But of course, there's other things we need to learn. We're also going to learn about OpenAPI. We're going to learn about Swagger. We're going to learn how you can import that into your own Postman. And we're also going to learn how to write an API in Python with just a simple Flask API. And we're going to use it to hack that ourselves. So I hope you guys stay tuned, because this is going to be an awesome course. Let's get into the first one. API 2009, API 1 2019, broken object level authorization. Now, if we look at this specific vulnerability, it's like, if, for example, if your request has an identifier, this is basically IDORs, what they're talking about. So if you heard about the term IDORs, insecure direct object references, they're referencing an object, which in this case can be a user ID, for example, and they're not doing it securely. Insecure. That means that unauthorized persons can grab data from other people because it's not secure, of course. So this might have a lot of very impactful consequences for your company. And it's really important one, in my opinion, because this one goes from sensitive data leakage to full account takeover, even if that's possible, because you might be able to change somebody's password. You might be able to request a password reset for your own account. That's also possible for other people's account, I mean, and get them in your own email inbox. So there's definitely some impact to be had here, and this is something that's also very important for bug bounty hunters, this vulnerability type. But of course, a lot of us know it as IDORs, which is kind of why I think OWASP is sometimes confusing. Sometimes they refer to IDORs. In this case, it's broken object level authorization. I get it. It's broken object, so it's broken authorization on the object level. The object is the identifier there, and it has broken authorization. But for me, it would be more useful if they kept using the same name, like insecure direct object reference is also a fitting name for me in this context. Now, there are basically two types of broken authorization level. The first one is based on user identifier. This one is going to be the most common. And as a bug bounty hunter and as a hacker, what you have to mostly do is look for parameters that are also hidden and test if those don't contain any IDORs, because there might be some parameters which are not even used, which might contain an IDOR. You never know. So I've included some coding in here as well, some examples. This is just pseudocode. In here, I basically get if user ID equals object.owner ID. So it's getting the user ID, and if it's equal to the object owner, then it's going to show data. else it's going to echo that you're not allowed to view that data, wait 5 seconds and redirect to the home page. So that's pretty much the safest way of handling that kind of code. But what can happen and what some developers do, and I get it, they reverse this. They say if not get user ID equals object owner ID, you're not allowed to view this data, wait 5 seconds and redirect home page. And then they have this show data here, which should never get reached because the redirect to homepage is getting triggered. But if the user presses backwards, it might get triggered in some browsers, this show data. So it's very important to program very securely and always look at the object level. If you have an object identifier in here, always see that you don't have broken access control issues there. Now, don't lead only, like if there's a get method, don't just keep it at the get, but in Burp Suite Pro, for example, you can transform your get methods to post methods. And that's also something you should test. Post, put methods, delete methods. So anything that's available for that specific identifier should be tested. It can also happen on an object ID level. So what that basically means is that because object IDs are passed to the server and the server might not check those object IDs properly, that user might be able to view data that he shouldn't be able to see. So let's see, this can happen very easily. For example, when developers need to secure some sort of resources and some not. So this is basically two types of broken authorization levels. So you have user ID level or object ID level. That's the difference. There's not much difference otherwise between them. It's just that some go for this is the specific user ID for this object and then I can show data. Some go for like this is the specific object ID. Is this user authorized to access this data? And the server might respond with yes or no. So what happens often, and that's what I've noticed as well from my bug bounty hunting, is that some developers will just totally forget to secure these types of things because they have like maybe a million different object identifiers that they need to look at. And they might forget to, that's why I hammered so much on also testing post, put, delete methods, because they might implement it on their get method, but they might forget to implement it on their post or delete method. I also have this on the example of a tag here. You see get product ID equals for the product details. You can also post them. That's what you should try at least. So creating a new specific product. What I didn't do here is put, which is something I should also do. So that's already 4 calls. There are many different calls that we can make to this specific product ID. What you should do is you should send an options. So I'm going to type it out real quick. Options. This will grab all of the specific methods that you're able to do on that HTTP method and on that specific URL. So what you can see here is another example. I've put in some examples in here to make it easier to understand. Again, not going to bore you to death with these examples. Feel free to go through them. But I think it's much more exciting if we actually see this in a lab. So going to go through this pretty fast, and then in the lab we can go in further detail. So how to detect and prevent broken object level authorization. That's something that's quite hard because for these vulnerabilities to be detected, we often need to understand the business logic quite well. And we need to, here it says test, read, update, and delete actions on all objects that we are authorized for. So we are not authorized for, should be that we are not authorized for. So we're going to basically test everything that we shouldn't be testing. We're going to replace every object ID with some object ID that's not ours, or we're just going to replace the header ID that we're currently testing with the other header of another person. It can be a session cookie, it can be a JWT token, but that basically indicates that, for example, if I am testing and I have 2 accounts, I'm going to want to automate this bug hunting. I want to automate hunting for this specific vulnerability. Now, what I can do is I can, of course, replace the object IDs everywhere. But the problem is that object IDs are never defined in the same way. Sometimes it's like product ID, sometimes it's like an invoice ID, sometimes it's person ID. So as you can see, there are many different ways to define these different properties. And it's really, it's not easy to automate that stuff. You can automate it for one specific program, but that will not work on a second program. It's really important to realize that, and that is why if I really want to automate it, I will always just replace the JWT token of my logged in user with the JWT token of another account that I own. That's very important to me because I'm testing sometimes on live data and I don't want to see data from other people. As a pen tester, as an ethical hacker, you are obliged, yes, to actually remain very sensitive with the data. You actually have to be very careful with that. Otherwise, you're not following your NDA, this non-disclosure agreement, basically. So be very careful with whatever you disclose. Of course, you can talk in general about things, but you should never go deep into detail. That's where things get very gritty. And never, ever, ever name the target name. Never, ever say exactly the scenario like you did it. Always leave out some detail. That's very important because, of course, you don't want to be liable for any damages that might occur from the hack springing up again and another hacker finding it and actually going to abuse it. So that's a little sidetrack there. To prevent this, try to use GUIDs if possible. I know it's a lot more complex and you're going to have to implement a lot more things, but it's helping a lot because a GUID makes it that the attacker has to guess the GUID before they can actually have an IDOR, or they have to have a endpoint that lists all the GUIDs. But of course, that's not always possible. So use an authentication token such as JWT and extract user ID from the JWT token. Never send the user ID as a parameter. That's not useful. Don't use a session cookie for that either, of course. But use just a JWT token because a JWT token will tell the server, hey, this is this person and maybe some other information about me in my specific JWT token. And the thing about JWTs is I can easily read them, but I cannot easily write to them and re-encode them properly. So that's why I say, and here I use an authentication token. That's also what OWASP recommends, by the way. You should create a centralized authorization solution and never have it be on all of the different nodes separately. That's very important because if you have duplication of code, that's going to be an issue because if you then have to change something, you have to change it at 50 different places because your code is duplicated very badly. That's very important. Centralized solutions, you can reuse those, just implement them from the interface. Use the authorization mechanisms to verify, read, delete, and update functions on every object that should be private. Of course, there are public objects as well, don't do it on them, but on every private object, make sure that you don't have any read, delete, or update that's going on in there. So as a conclusion, I really like this type of vulnerability. It has a lot of potential, and I think there's a lot of undiscovered vulnerabilities like this out there. So if you see it, user ID, just change it, but don't change to a random user ID. Make second account so you're actually testing with two of your own users. Otherwise, you might get into trouble. All right, moving on. We're going to API 2. Now for API 2, broken user authentication, this can also entail a lot. So first of all, it's not easy to always implement the authentication program correctly. A lot of developers and architects get confused by what to include in the authentication control and what not, guys, because these days a lot of software is made up of these micro APIs. Micro APIs just little servers that have a little bit of functionality that are always communicating with each other, and it's really easy to overlook some of these endpoints. So very, very important that you do these steps that we'll show you later on. This vulnerability, it can easily lead to complete account takeover. That's not something you want at all, but it can be very varied. That's something you need to know as well. So if your API, for example, allows for credential stuffing, that is not good. Your hacker will try to brute force credentials, but they should lock out after a certain amount of time, after a certain amount of attempts. The system should just lock out the attempting user. Now, if the API endpoint does not verify the request with a CAPTCHA, that's something that's also bad, because those CAPTCHAs do have a meaning, guys. So if you see an endpoint with no CAPTCHA, as a pen tester, definitely report it if it's authentication based. When the endpoint uses get parameters, that's also not good. I know that you can't read get parameters from HTTPS, but still I don't like it when I see get parameters with some sensitive information. It's always a possibility that it gets sent over HTTP instead of HTTPS, and then I still have my parameters, which is not good, of course. Our endpoint also has issues. When our endpoint issues a token such as JWT, but does not verify it. And yes, this has happened before, where it actually, I got a JWT token, but the system didn't verify it. So it was never used anywhere. Every parameter in my requests said user ID equals, so that's what was used there. So yeah, like I've never, besides that, I've never really come across it, but it's something you should definitely verify. And when we use that JWT token, be aware that there are ways to, how do I put this? There are ways to sign your token again with the non-algorithm, for example. So a JWT token is basically a string of characters that is signed with a specific algorithm. That algorithm has a public and a private key sometimes, and you need that key to unlock it. You need to repackage your JWT token, because what will often happen is you can always read a JWT token. So the server will read, okay, this is specific user, blah, blah, blah. And if I want to change that user ID equals in your JWT token, I'm going to have to, first of all, hack your private key, because otherwise I cannot do that. But some servers are incorrectly configured, and that will allow for things like JWT on signing with the algorithm nonce. That's something that you don't want, because of course then I can just force a JWT token and it can become anybody that I want, and that's not intentional. So what's also really important is that your endpoints should verify the validity of the JWT token. It can be expired, a JWT token, or JWT, as you should say, and a session token as well. It should always be verified if those are still valid, if they want to be accepted. And if there's of course the easy to guess keys, like a birthday attack. That's an easy attack. You can look that up on the internet, or they might be easy to crack. And I know MD5 is not super easy to crack, but in the last years some really good progress has been made in cracking MD5. I encourage you to look it up. It's really interesting in how the developers got that far to the point where they are now. So let's talk about some scenarios. Let's say the attacker is requesting a password reset. Okay, so he gets a specific password reset call for user ID is equals 1234. And this will trigger a password reset for that specific user, Rat. Let's just call him Rat. And the user will receive a password reset token in the mailbox with a 4-digit, like this token ID equals blah, blah, blah. But since there is no rate limiting on the endpoint, the attacker can try to send all of the 4 digits in rapid succession, like from 0000 to 9999. It's going to send it really fast for this specific user 123. And what's going to happen then is, of course, first of all, we need to request a password reset, because otherwise there's no token generated. And if we can try all of the combinations then, and none of them is going to be valid because no token has been generated yet. So okay, they're going to generate a token here, and then I'm going to just brute force guess this. And that's also, of course, a misconfiguration about authorization, because I need to be very careful about what types of passwords, well, I forgot what I was going to say, not important. Let's move on. JWT validation accepts the non-algorithm. This is the one I was talking about before. As you can see, you can always decompile the JWT token. This is a real JWT token, by the way, that I made. And then, of course, you can re-encrypt it sometimes with the algorithm nonce if your server is incorrectly configured. That's possible, and then you also have a pretty big issue on your hands. Now, there are some preventive measures you can take. It's really important to map all of your flows. Make sure that you have all the flows: mobile, deep links, one click, desktop application, IoT, mail carrier, pigeon. I don't care, just all of the flows need to be mapped out. Understand exactly how your authentication mechanism works. Like, you have one authentication mechanism, map out to what it's connected, and then tell yourself how it works. Try to explain it to somebody else, maybe even, because if you explain things to somebody else, you realize where the gaps in your knowledge are. That's that's a powerful tool that I often use. Do not implement your own authentication mechanism, guys. These what exists have been tested and tested over and over again. Don't go reinventing the wheel, there's no point in it. So all authentication endpoints, really important, including the forgotten password, should be protected by rate limiting. If the user keeps on sending requests, they should be locked out for a specific time. Now, they have to be a lot stricter, these rate limiting endpoints, than on, let's say, just a random endpoint to get the products. Well, of course, that's also very bad, but it's a lot worse if you actually do that on a forgotten password or on a login or logout. If you can brute force it, that's never good. And the OS authentication cheat sheet, that's a really great reference for implementing authentication. I use it all of the time, so definitely go there. And if possible, you should always implement multi-factor authentication. That's something that's very important, and I'm saying multi-factor because I don't mean entering two passwords. I do mean multi-factor, meaning one password and a phone, or one password and an authenticator, or one password and whatever, as long as it's an external authenticator and not just the same password or the mail of the user, because you should always assume that the user is compromised, so even their mail is not safe, and that's why one of those authenticators is probably your best solution. Now, you need to implement CAPTCHA mechanisms everywhere that you can, especially on the login pages and on the forgotten password pages. Those are very vulnerable to these kinds of attacks. Of course, because it's very easy to try and break these if you can just brute force them. That's not something we want. We want to lock people out after a certain amount of time. Do not use API keys for authentication. These should be used for client app authentication. So what I mean is, do not use API keys for the authentication of the user. They should always be used for client app authentication. So if the client wants something, they should be the one who gets the request, or if the app wants something, they should be able to communicate with the client. So this is a pretty good vulnerability type. I like it. I'm not gonna lie, I really do. And this is something that I look for often. But when dealing with these authentication endpoints, I really need to make sure that whatever we do, a very strict security policy is in place. Much more strict than on normal endpoints. And you need to be sure to have a good rate limiting, lockout and captcha mechanisms. This is going to prevent, and I say prevent because this is not going to stop an attacker. If they're really determined, they will find a way around it. So that's why it's important that we are always trying to be one step ahead of them. So attackers can brute force, you can lose your entire system because of that. Because if they brute force too hard, they are sending way too much requests to the server, and the server might fall over. And that's of course also not a good thing. Besides stuffing your APIs, which is also not a good thing, of course. So make sure that you implement safe authentication and don't just implement things that you created yourself in a weekend. Don't do hobby projects when it really matters, guys. So that was number 2. Let's go over to number 3, shall we? We have excessive data exposure. So what exactly is excessive data exposure? Well, it's when the UI doesn't need specific data that the API does return. For example, if the UI does not need the card number, but it only needs the if it needs the card number and the validity, but it doesn't need the CVV. When it does get returned that CVV for a specific card, so if I get a CVV for my card, that's not a good thing for the API, because if there's a man in the middle attack, somebody can always try to intercept his traffic and see what happens. So that's why it's always wise to not throw too much information out to the front end. Always think about, okay, what needs to be in the front end? What do I need here? Do I need this comment? Yes, okay, comment is needed, ID is needed. User might be something questionable, but then we have user address and user email. That's definitely not in there. So that's definitely way too much information, and it's just not that's just not how it works. We should not return that information. We should always look at all of the responses returned, and we should filter out data. So we don't want to rely on the client to filter out that data. We want the data gone by the time it leaves the API. That's super important. And then we should review all of these responses from time to time. This is a recurring meeting. This is not something that stops on one day. So you need to do that every time and time again. You need to see what's coming from the backend, and you need to see if there's any sensitive data coming from it. It's really hard to automate this. This is why there's a lot of vulnerabilities like this out there. But as a bug bounty hunter, I also realized that it's usually not going to be very impactful. So be careful with reporting this. Make sure that if you do, you have some really good impact you could show. But if you don't have really good impact, then just assume that, okay, this is an issue, but it's not something that a lot of bug bounty platforms will accept. At least not, and I think, but if anybody disagrees, or if anybody's like, okay, this is like a lot of bug bounty platforms will accept this vulnerability type, feel free to let me know, because I'm open to all of that discussion. Just tag me on Twitter. What's also important is that there are generic methods like toJSON, toString. If you pass an object to those methods, you're going to have a problem, because they're going to send out all of the data for that specific object. And that's not good, of course. We only want certain fields, so it's important that you don't use these generic functions, but actually go for the object specifically that you need. I have a lab as well, which actually has one of those objects, and it has only exactly what it needs. So it is very important. As an extra layer of security, implement an automated scheme-based validation for all of the responses, and that's going to check by the scheme that we define if the response does not contain too much data. Now, the big disadvantage of this is that it's costly to set up and costly to maintain, because you need a good program, of course, to do this. So that was it for this one. I know this one was a little bit shorter, but it doesn't always have to be a long one, right? So I'm going to cut off the video here. We're going to do 3, 4, and 5 in the next video. If we didn't already do 3, well, I just did 3. So let's do 4, 5, and 6 in the next video. Thank you very, very much for watching, Amazing Hackers. I hope you're doing well, and I will see you in the next one. Bye, Amazing Hackers!